Hi there, my name is Krishna and today I am going to go through you all with the concept of stack and see array-based stack implementation. First, let me tell you one thing. This is a project of Comp 251 data structure course in UFV, instructed and requested by Professor Lili Saghafi. Stack. It is a dynamic data structure whose size constantly changes as items are pushed and popped from the stack, means added and removed. It follows LIFO last in first out method, means the recently added items is the first to be out and first item added is the last one to be out from the stack, that is FILO. Basic operations like push and pop takes place at the top. A real world example of a stack can be stack of books or a stack of plates. Then we have stack operations. First, we have isempty that checks if the stack is empty or not. Then we have push that insert or add element in the stack. Then we have pop that delete or remove element from the stack. Then we have peek, it retrieves the stack's top entry. And the last is clear that removes all the entries from the stack. Now take this as a stack representation and we add few elements on the top of each other where top always represents the topmost element. Now when we logically implement stack like this, then the direction of a stack is upwards. That is, if we add another element, it would come at the top of element 3 and our stack will grow in size upwards. But when we implement stack using arrays, suppose we take an array of 5 elements, then the direction of stack would be towards right in our logical representation. That is, when we are representing stack using arrays, we'll add elements from left to right. So let's add our first element and we will use a top variable for insertion, deletion and accessing the element at the top. So currently our variable top will be at index 0 and to add another element we will increment our top by 1 and then we can simply add the element at that position. So in this way we can represent stack using array. Here we have the push method that checks whether the array has room for a new entry by calling the additional private method, that is ensure capacity. If necessary, ensure capacity resizes the array, avoiding a stack that has no room for a new entry. The uh, push method then places the new entry immediately after the last occupied location in the array. To indicate the empty stack array, we have assigned -1 to the top index as its initial value. This choice allows push to simply increment top index before using it when placing a new entry in the array. If we want to remove the top entry from the stack, first we have two methods. First is by decrementing top index, like here we have the array where we have 4 indexes 0, 1, 2 and 3 and the stack will be having 4 elements, element 1, 2, 3 and 4. And if we want to remove the third index entry, that will be our element 4, then it will be returned to the client and the top entry of our stack will become the element 3 and the top index will be our 2. And the second method for doing this is by setting stack top index to null and then decrementing top index. Similarly, if we consider the array where we have 4 indexes 0, 1, 2 and 3 and a stack where we'll be having 4 elements, then for doing so we will be considering the third index array to the null and it will return to the client, and here also the top entry of the stack will become the element 3 and the top index will become the sec 2.